Imagine a nation rising from the ashes of war to not just rebuild, but to dominate a technology so fundamental it would define the modern world. In the 1980s, Japan didn't just participate in the semiconductor race, it was the race. By 1989, 6 of the top 10 global semiconductor companies were Japanese. They controlled over half the global market for these critical components. This wasn't just an economic boom, it was technological supremacy, a stunning display of industrial might that sent shockwaves across the globe. Now, imagine American tech giants, the very inventors of the transistor, the pioneers of Silicon Valley, suddenly finding themselves on the defensive. Picture them outmaneuvered in quality, price, and innovation, lobbying their government not for protection from imports, but for access to a foreign market that seemed all but impenetrable. This wasn't a hypothetical scenario. This was the stark reality US chip makers faced against the Japanese semiconductor juggernaut in the 1980s. So, what truly happened? How did Japan orchestrate this stunning technological conquest, becoming the undisputed king of memory chips? And more puzzlingly, how did this empire, built on precision and foresight, crumble so dramatically, its market share plummeting from over 50% to less than 10% today? Is its recent multi-billion-dollar gamble, a flurry of new factories and ambitious partnerships, a genuine shot at a comeback, or a final desperate echo of past glory? From the rubble of World War II, Japan embarked on an economic miracle. But it wasn't just about rebuilding, it was about conquering new frontiers. And the newest, most promising frontier, the very bedrock of the coming digital age, was the semiconductor. The national will was focused, the ambition immense. This transformation was no accident. It was the result of deliberate, strategic cultivation. At the heart of this strategy was the Ministry of International Trade and Industry, or MITI. MITI wasn't a passive observer. It was an active conductor of Japan's industrial orchestra, providing strategic guidance, channeling subsidies, and orchestrating crucial R&D collaborations. A prime example of MITI's influence was the government-led VLSI, Very Large-Scale Integration Project, launched in 1976. With a substantial $300 million investment, a significant sum at the time, MITI brought together 6 major Japanese computer and electronics companies: Fujitsu, Hitachi, NEC, Mitsubishi Electric, NTT, and Toshiba. This wasn't merely about distributing funds. It was a concerted effort to create a common technology platform, fostering innovation and information sharing among rival companies. The project established joint laboratories focused on fundamental semiconductor technology, pushing the boundaries of what was then possible. This collaborative spirit, even among competitors, allowed for rapid advancements. Within 4 years, the VLSI project yielded critical breakthroughs, including the development of electron beam lithography, EBL, a revolutionary chip-making technology later commercialized by global giants like ASML, Nikon, and Canon. The impact was transformative. These technological leaps were instrumental in Japanese firms capturing an astonishing 51% of worldwide semiconductor sales by 1988. This government-led initiative was powerfully amplified by Japan's unique industrial structure, the keiretsu system. These were not just loose business affiliations, but vast, interconnected groups of companies, often centered around a main bank and a trading company, encompassing manufacturers, equipment suppliers, and financial institutions in a tightly woven fabric. This vertical and horizontal integration fostered an environment of close cooperation, ensuring stable supply chains, facilitating long-term investment horizons, and enabling the rapid dissemination of technological advancements. The keiretsu structure allowed for internalizing input costs and achieving a close level of coordination, a stark contrast to the more fragmented and often adversarial supplier relationships prevalent in the United States at the time. Unlike the often adversarial supplier relationships in the West, Japan's keiretsu acted like industrial families, sharing knowledge, resources, and risk. This allowed them to focus on long-term quality and innovation, rather than just short-term profits. The system wasn't just about individual company brilliance. It was a nationally orchestrated symphony where government policy and a unique industrial ecosystem worked in perfect concert. This created a formidable, almost closed loop of innovation and production, allowing Japan to rapidly catch up and then surpass its international competitors. The early focus on collaborative R&D within projects like VLSI, even among rivals, was a key differentiator. While Western firms often engaged in secretive, highly competitive R&D, Japanese companies, by sharing foundational research, could avoid redundant efforts and collectively solve fundamental technological hurdles faster. Once these basics were established, they could then compete fiercely on implementation, manufacturing excellence, and incremental innovation. Japan's strategic decision to focus on dynamic random access memory DRAM chips proved to be a masterstroke. As the workhorse memory chips for the burgeoning computer industry, DRAMs were in escalating demand. Japanese companies didn't just enter this market, they set out to dominate it. They achieved significant breakthroughs in DRAM manufacturing processes, leading to higher yields, superior quality, and lower costs compared to their American counterparts. They didn't just make DRAMs, they perfected making them. The result was a product that was higher quality, more reliable, and often cheaper than anything coming out of America. The market share data tells a staggering story. By 1988, Japan's overall global semiconductor sales had reached 51%. In 1991, their world production share for all semiconductors stood at 39%. However, their dominance in DRAMs was even more pronounced. As early as 1987, Japanese manufacturers controlled an estimated 75% of the global DRAM market. This overwhelming control had significant repercussions. US computer makers, initially reliant on domestic chip suppliers, increasingly turned to Japanese DRAMs due to their superior quality, reliability, and availability. This created a dependency that deeply alarmed both the US industry and its policymakers. Imagine this. American computer companies, the very pioneers of the PC revolution, increasingly had to buy the most critical component, memory, from their fiercest economic rival. That was the power Japan wielded. This DRAM dominance was not merely about designing a superior chip. It was fundamentally about mastering the mass production of a standardized high-volume commodity chip with unparalleled quality and cost-effectiveness. This was a story of manufacturing prowess as much as, if not more than, a story of pure technological invention. The Japanese keiretsu system, with its embedded philosophy of continuous improvement, kaizen, and tight control over the entire supply chain, was perfectly suited to this challenge. While US firms were often more focused on groundbreaking design, Japanese companies were winning on the factory floor, a strength that was perhaps underestimated by their competitors at the time. This manufacturing excellence, applied to a critical commodity component, created not just an economic advantage for Japan, but a significant strategic vulnerability for the United States. Control over the supply of DRAMs, essential for computers and the entire spectrum of emerging electronics, gave Japan immense leverage, a factor that would directly precipitate an aggressive response from the US government. As Japan's semiconductor star ascended, casting an ever larger shadow, the United States semiconductor industry and its government grew increasingly alarmed. The sheer scale of Japan's success, particularly its stranglehold on the DRAM market, was perceived not just as an economic challenge, but as a strategic threat. Two primary accusations were persistently leveled against Japanese manufacturers: dumping, the practice of selling chips below their cost of production to aggressively gain market share, and the maintenance of a closed Japanese market, which severely limited access for foreign, especially US chip makers. The US industry, primarily through the influential Semiconductor Industry Association, SIA, complained bitterly about these perceived unfair practices. They pointed to stark market share disparities as evidence. For instance, in 1984, US producers commanded over 83% of their own domestic market and a healthy 55% in Europe. Yet, in Japan, their share was a mere 11%. This, the SIA argued, was circumstantial evidence of significant trade barriers preventing fair competition. The frustration boiled over into action. In June 1985, Micron Technology, a smaller US DRAM maker, filed an anti-dumping complaint. This was quickly followed by similar actions from industry giants Intel, AMD, and National Semiconductor concerning EPROMs, erasable programmable read-only memories. In an almost unprecedented move, the US Commerce Department even self-initiated an anti-dumping case on 256K and future generations of DRAMs in December 1985. The tide was turning. The culmination of this pressure was the 1986 US-Japan Semiconductor Agreement. This landmark accord, effectively forced upon Japan to avert escalating trade sanctions, was highly controversial and destined to have profound, long-lasting impacts on the global semiconductor landscape. The agreement had two main pillars. First, Japan committed to ending the dumping of semiconductors in world markets, not just the United States. This was to be enforced through a fair market value, FMV system, under which the US Department of Commerce would determine and set minimum price floors for Japanese memory chips sold in the US and, by implication, influence global pricing. Second, and perhaps more contentiously, Japan agreed to actively help secure 20% of its domestic semiconductor market for foreign producers within 5 years. This was an exceptional demand for a specific, quantitative outcome, rather than a more general commitment to market access principles. Tsugio Makimoto, who was chairman of the Electronic Industries Association of Japan's, EIAJ, electronic device group at the time, and a member of the Japanese negotiation team, provides a crucial first-hand perspective on the agreement's implementation. He notes that during the agreement period from 1986 to 1996, the share of foreign-made semiconductors in Japan dramatically improved. It rose from less than 10% in 1986 to exceed 20% by 1992, and further surpassed 30% by the year 2000. Makimoto explicitly states, "The government of Japan played the most crucial role for increasing the share of foreign semiconductor products in Japanese market. They fully utilized their administrative power to encourage semiconductor users in Japan to use foreign products more preferentially than Japanese products." This indicates a significant government-directed effort to comply with the terms. The immediate impact of the agreement was multifaceted. It undoubtedly weakened Japanese semiconductor firms by restricting their aggressive pricing strategies and forcing them to concede a portion of their highly protected domestic market. Concurrently, the agreement, coupled with proactive US government initiatives like Sematech, a semiconductor cooperative development organization established in 1987 with $100 million in annual government support, helped to revitalize US competitiveness. Indeed, by 1993, the US had reversed Japan's lead and reclaimed the top position in global market share. The 1986 agreement, therefore, was far more than a simple trade adjustment. It was a direct geopolitical response to one nation's overwhelming economic dominance in a critical technology sector. It demonstrated how national security concerns, specifically the perceived vulnerability stemming from dependency on foreign-supplied critical technology, could lead a major economic power like the United States to mandate market outcomes, prioritizing its domestic industry's survival and competitiveness, even if it meant diverging from pure free market principles. However, the agreement also unleashed complex and, in some cases, unforeseen ripple effects. The fair market value, FMV system, meticulously designed to prevent Japanese companies from dumping memory chips at artificially low prices, had a significant unintended consequence. While it constrained Japanese producers, it inadvertently created a price umbrella that greatly benefited the emerging DRAM manufacturers in South Korea. At the time, Korean DRAMs were considered foreign-made in Japan, and thus helped fulfill the 20% market access quota. Crucially, however, Korean products were not subject to the FMV restrictions imposed on Japanese chips. This loophole allowed Korean manufacturers to price their DRAMs more freely and often more competitively, undercutting the FMV-constrained Japanese chips both in the Japanese market and globally. As Makimoto observed, the FMV system of memory introduced as a part of the agreement helped boost the rapid growth of Korean manufacturers. Because it was not subject to FMV restrictions, price setting was freely done, and they expanded the sales in the world market. This dynamic was a key factor in the dramatic reshaping of the global DRAM market, a clear example of how targeted trade interventions can yield complex and unexpected outcomes. While Japan grappled with the ramifications of the 1986 agreement, new semiconductor powerhouses were rapidly emerging in Asia, fundamentally altering the competitive landscape. South Korea and Taiwan, each with distinct strategies, capitalized on the shifting dynamics. The emergence of Korean rivals was nothing short of explosive. South Korean conglomerates, known as chaebols, particularly Samsung and later SK Hynix, embarked on an aggressive, state-supported expansion into DRAM production. They astutely recognized the opening created by the pricing and market constraints imposed on their Japanese competitors. Their strategy was one of intense focus, specialization in DRAMs, coupled with massive and sustained capital expenditure. Between 1987 and 1992, for example, Samsung's capital expenditures accounted for approximately 40% of its revenues, a figure roughly double the semiconductor industry average at the time. This investment wasn't just in capacity, but also in rapid technology adoption and achieving price leadership, often by operating on thinner margins to capture market share. The results were dramatic. As Tsugio Makimoto documented, the global market share of Japanese DRAM rapidly declined from about 75% to about 20% in 14 years, from 1987 to 2001, while Korean DRAM increased sharply from about 5% to 40%. In this process, the shares of Japan and Korea reversed in 1998, and since then, Korea became the DRAM kingdom. Simultaneously, Taiwan was pioneering a revolutionary business model that would reshape the entire semiconductor industry. Companies like Taiwan Semiconductor Manufacturing Company, TSMC, founded in 1987 by the visionary Morris Chang, and United Microelectronics Corporation, UMC, championed the pure-play foundry model. This was a radical departure from the prevailing integrated device manufacturer, IDM model, where companies like those in Japan designed, manufactured, and sold their own chips under one roof. Chang's insight was that a new ecosystem of fabless companies could flourish if they could focus solely on chip design and outsource the hugely capital-intensive manufacturing process to specialized foundries. The Taiwanese government played a crucial enabling role in this development, with institutions like the Electronics Research and Service Organization, ERSO, actively involved in spinning out and supporting early foundry ventures like UMC and providing foundational R&D for TSMC. This foundry revolution had a profound impact on Japan. Japanese firms, heavily invested in the IDM model and having achieved mastery in memory chips, were slow to adapt to this new paradigm. They largely missed the explosive growth in logic chips, such as microprocessors, which became central to the personal computer revolution and were the primary customers of the burgeoning foundry industry. While Japan was the king of memory, a new kingdom was rising in Taiwan, built on a completely different philosophy: making chips for others. This was the foundry model, and it would change everything. The ascent of Korea and Taiwan was not merely a story of cheaper labor. Korea achieved remarkable scale and eventually technological leadership in DRAMs through highly focused, state-supported, and aggressive investment. Taiwan, on the other hand, didn't just compete in an existing market. It innovated a new business model that fundamentally restructured the global semiconductor value chain, enabling a whole new category of successful enterprises: the fabless design houses. Japan's IDM model, which had excelled in the mass production of standardized memory chips, proved less agile in responding to the rapidly diversifying demand for specialized logic chips driven by the PC boom. The foundry model, by its very nature, catered perfectly to this diversification, allowing numerous specialized design firms to emerge and innovate without bearing the colossal expense of building and operating their own fabrication plants. These developments in Korea and Taiwan illustrate two distinct yet highly successful paths for latecomer industrialization in a cutting-edge, capital-intensive sector. Korea pursued a strategy of focused mass production and rapid scaling within an existing high-volume product category, DRAMs, effectively leveraging state support and the unique capabilities of its chaebol structures. Taiwan carved out and then dominated a new niche and business model, the foundry, also benefiting from initial state R&D support, which in turn enabled a different segment of the semiconductor ecosystem, fabless design, to flourish. Both strategies posed formidable, albeit different, challenges to the incumbent Japanese industry. Japan's decline was thus accelerated because it faced multifaceted competition, from Korea in its traditional stronghold of memory chips, and from Taiwan through a disruptive new business model that captured the burgeoning market for logic chips. While external pressures from the US trade agreement and the rise of aggressive new competitors in Korea and Taiwan played undeniable roles, Japan's semiconductor decline was also significantly driven by internal fault lines. The very structures and strategies that had propelled its ascent began to act as anchors in a rapidly changing technological sea. The dominant integrated device manufacturer, IDM, model, once a source of strength through tight control over design and production, became a cumbersome constraint. Major Japanese electronics conglomerates like NEC, Toshiba, Hitachi, Fujitsu, and Mitsubishi Electric, which collectively accounted for over 60% of Japan's semiconductor production, operated with a department store-style product composition. They handled a vast array of diversified products across numerous fields, including memory, microcomponents, logic, and analog chips, largely because these semiconductors were historically developed for internal consumption within their own diverse electronics divisions. This approach, while fostering synergy within the conglomerates, spread R&D resources and capital investment thinly across too many fronts. It proved far less efficient than the specialized foundry model, which allowed fabless companies to pour all their energy into cutting-edge design, and foundries to achieve unparalleled manufacturing excellence and economies of scale by serving multiple customers. Compounding this structural rigidity were elements of corporate culture and strategic misjudgment that hampered adaptability, particularly during Japan's lost decade of economic stagnation in the 1990s. There's evidence to suggest that the extraordinary success of the 1980s bred a degree of complacency, a phenomenon described as success leads to arrogance. Some executives reportedly came to believe there was nothing new to learn from the West, and that even English, the language of business, was no longer relevant. Such insularity in a globalized, fast-moving industry was undoubtedly damaging. Furthermore, the traditional consensus-based decision-making processes within many large Japanese corporations, while fostering stability, often resulted in slowness to react to abrupt market shifts. There was a palpable aversion to radical restructuring or abandoning legacy businesses, even when their competitiveness was clearly waning. This was cited as a contributing factor in the eventual failure of Elpida Memory, a government-backed attempt to consolidate Japanese DRAM operations. The financial pressures of the lost decade also led to critical underinvestment in R&D for next-generation chips, especially in the burgeoning field of logic devices where US firms were excelling. As one analysis notes, Japanese firms suffered from underinvestment in the aftermath of the economic bubble burst and inefficient vertical management structures. Many firms resorted to downsizing their workforce and R&D activities. This period of reduced investment coincided with rapid technological evolution globally, creating a gap that became increasingly difficult to bridge. Strategic missteps further compounded these issues. There was a failure to accurately anticipate key demand drivers. The Olympic rule anecdote, where NEC supposedly anticipated a massive HDTV boom in 1992 that never materialized, forcing an overinvestment in 6-inch fabs just before the industry shifted to 8-inch, illustrates a misjudgment of market trends. More critically, Japanese industry largely missed the tectonic shift towards personal computers and the corresponding surge in demand for microprocessors and other logic chips, a domain where US firms like Intel thrived and which the Taiwanese foundry model was perfectly positioned to serve. Even in manufacturing, a traditional Japanese strength, questionable choices were made. In the early 1990s, the prevailing philosophy in Japan, championed by Dr. Tadahiro Ohmi, focused on achieving ultra-clean manufacturing environments. This was contrasted with the yield management approach, involving intensive inline monitoring and process control, which was being successfully adopted by Korean competitors. It was a tale of two philosophies. Japan bet on perfect cleanliness, Korea on constant monitoring and adjustment. Korea's bet paid off massively, leading to higher yields and lower costs, especially as they embraced 8-inch wafers, while Japan was still heavily invested in its 6-inch capacity. Finally, financial headwinds added to the pressure. The sharp appreciation of the yen following the 1985 Plaza Accord made Japanese exports significantly more expensive. Later, the Japanese banking crisis of the 1990s severely constrained the availability of capital for investment, with firms often reluctant to seek funding outside their traditional keiretsu banking relationships. These internal weaknesses, cultural inertia, the rigidity of the IDM model, critical strategic miscalculations in market direction and manufacturing philosophy, and underinvestment during a crucial period were arguably as significant, if not more so, than the external pressures from the US trade agreement and the rise of new rivals. The external shocks served to expose and exacerbate these pre-existing internal vulnerabilities. Had Japanese firms demonstrated greater agility, a willingness to adapt their business models more rapidly, for instance, by embracing the foundry model for logic chips earlier, and a commitment to investing in new growth areas, even during difficult economic times, the impact of these external shocks might have been substantially mitigated. The lost decade was not merely an economic slowdown for Japan's semiconductor sector. It was a period where the nation lost its innovative momentum. This failure to keep pace with investment cycles and technological shifts, while rivals surged ahead, created a competitive deficit that proved incredibly challenging to overcome in the years that followed.